Overnight, this winter storm adjusted its track. Not dramatically, not hundreds of miles, just enough. But in winter weather, just enough is the difference between manageable snow and massive totals. Areas that were expecting moderate accumulation are now inside the heavier snow corridor. And when a storm shifts like this with deep cold air already in place, impacts escalate quickly. This isn't hype, it's physics. A small movement in the storm center has repositioned the heaviest lift, strengthened snowfall rates, and increased the risk of disruptive travel during the peak window. And if you're in the newly favored zone, totals may be significantly higher than yesterday's forecast. Tonight, we are breaking down exactly what shifted, who is now most at risk, and why the next several hours will determine how serious this event becomes. Because this storm didn't weaken, it recalibrated. And now the target area is larger, and the totals are climbing. One small track changes create massive outcome differences. This is where most people underestimate winter storms. They look at the map and see a slight adjustment. Maybe the storm center nudged north 75 miles. That doesn't sound dramatic. It doesn't look dramatic, but in winter meteorology, that is everything. Winter storms are precision systems. They are not like summer thunderstorms scattered across a region. They are structured, layered, and incredibly sensitive to positioning. The exact location of the low-pressure center determines where lift is strongest, where moisture wraps in, and where the heaviest snow bands lock into place. When the track shifts, the entire snowfall axis shifts with it, and that axis is where totals explode. Imagine a corridor that was previously forecast to receive moderate snow. Enough to shovel, manageable for plows, inconvenient but not crippling. Now move the storm 50 to 100 miles closer to that corridor. Suddenly the strongest forcing overlaps with deep cold air. The lift intensifies. Snowfall rates increase. Banding develops. Instead of steady light snow, you get concentrated bursts. Instead of 4 to 6 inches, you're looking at 8 to 12 inches, possibly more if a band stalls. That is the difference a small shift makes. And it doesn't stop there. A slight northward jog can also pull warmer air aloft into areas that were previously all snow, changing precipitation type along the southern edge. At the same time, it's areas north of the low experience stronger frontogenesis, the atmospheric process that enhances snowfall rates. So what appears to be a minor repositioning is actually a reconfiguration of the entire storm structure. This is why forecasts can change quickly within 24 hours of an event. Once the storm begins organizing and its true strength becomes clearer, models refine its path. And when they do, snowfall projections adjust accordingly. The shift we're seeing now is not cosmetic. It places a larger population zone into the higher impact quadrant of the storm. And in winter weather, being inside or outside that quadrant is the difference between routine accumulation and a disruptive event. This is the nature of winter systems: tight gradients, sharp cutoffs, and dramatic differences over short distances. A county 30 miles west might measure double the snowfall of a county 30 miles east. A city expecting manageable totals can suddenly find itself under the deformation band, the engine room of the storm, where snow falls harder and longer than originally projected. So when we say the storm just shifted, we are not describing a minor tweak. We are describing a fundamental change in who gets the brunt of the impact. And that is why tonight's update matters. Because in winter forecasting, inches are determined by miles, and miles are determined by track. And right now, that track has moved. 2. The cold air was already in place. A winter storm can only become significant if the atmosphere is prepared for it. And in this case, the preparation was already done. Before this system even arrived, cold air had settled in across the region. Our surface temperatures were below freezing. Ground temperatures had dropped. The air column from the surface up through several thousand feet was cold enough to support efficient snowfall. That matters more than most people realize. When cold air is shallow or marginal, storms struggle. Snow mixes with rain. Accumulations melt on contact. Totals underperform. Forecasts bust low. But when cold air is deep and established, the storm does not have to fight the environment. It works with it. And that is exactly what is happening here. This storm is moving into an atmosphere that is already primed. There is no warm ground to overcome. There is no borderline temperature profile. There is no delicate balance that could easily tip toward rain. Instead, there is a stable, cold base layer waiting for moisture and lift to arrive. That combination is powerful because when strong lift intersects deep cold air, snow growth becomes highly efficient. Snowflakes form in the optimal temperature zone within the cloud, what meteorologists call the dendritic growth layer. When that layer is deep and saturated, snow crystals grow larger and fluffier, and that means accumulation happens faster. 1 inch per hour becomes possible. In stronger bands, even 2 inches per hour is achievable. Roads deteriorate quickly under that kind of rate. Plows struggle to keep pace. Visibility drops sharply. This is not a marginal setup where totals are dependent on perfect timing. This is a thermodynamic environment that supports heavy snowfall if the storm track cooperates. And now that the track has shifted, the overlap between lift and cold air is stronger. That overlap zone is where totals increase. Another critical factor is snow ratio. In colder environments, snow can fall at higher ratios, meaning more inches of snow per inch of liquid precipitation. Instead of heavy, wet snow compressing quickly, you can see fluffier accumulation that stacks up rapidly. That changes impact. Fluffier snow blows and drifts more easily. It reduces visibility faster. It creates whiteout potential when wind increases. And because temperatures are already cold, melting during peak snowfall is not a factor. Everything that falls sticks. This is why the shift in storm track is more consequential than it would be in a borderline temperature scenario. If this were a near freezing setup, the shift might only slightly increase totals, but with entrenched cold air, the atmosphere is fully supportive of whatever moisture the storm provides. The system does not need to generate its own cold. It has it. And that is why this adjustment in track now carries more weight. Because when a storm meets a ready atmosphere, it does not waste potential. It converts it into accumulation. And right now, the atmosphere is ready. 3. Snow banding will decide who gets the jackpot. When people hear a snowfall forecast, they imagine a steady, uniform blanket of snow covering an entire region evenly. That is rarely how major winter storms actually behave. Instead, they organize. Within the broader shield of precipitation, narrow corridors of intense snowfall develop. These are snow bands, focused areas where lift is maximized and snowfall rates dramatically increase. And they are the difference between a routine event and a headline-making total. Inside one of these bands, snowfall rates can reach 1 to 2 inches per hour, sometimes even higher for brief periods. Visibility drops rapidly. Roads become snow-covered within minutes. Plows can barely keep up. But step just 30 to 50 miles outside that band, and conditions are noticeably different. Snow still falls, but at a lighter, steadier rate. Accumulations build more slowly. Travel remains manageable longer. This sharp contrast is one of the defining characteristics of winter storms. The reason these bands form comes down to atmospheric dynamics. As the storm strengthens, temperature gradients tighten, frontogenesis intensifies, air is forced to rise along narrow zones where warm and cold air masses clash. That rising motion enhances precipitation efficiency. The stronger the forcing, the more intense the snowfall. But these zones are precise. They are not broad swaths covering entire states. They are targeted corridors. And here is where it becomes critical. Once a band sets up, it can stall. If a snow band locks into place over a metro area for 3 to 5 hours, totals can double compared to surrounding regions. What was forecast as 6 inches becomes 10. What was projected as 8 inches becomes over a foot. That is how jackpot zones form, and they are notoriously difficult to pinpoint perfectly until the event is underway. Even the best forecast models can struggle with exact band placement more than 12 to 18 hours in advance. They can show the general corridor, the region most favored for heavy snow, but the precise location of the most intense banding often refines closer to real time. That means small shifts in storm strength, track, or timing can nudge that band slightly east or west. And that slight nudge determines who gets the highest totals. Right now, the recent track adjustment increases the likelihood that stronger banding will develop farther into the newly favored zone. The ingredients are aligning: strong lift, deep moisture, established cold air. If those elements overlap efficiently, intense banding becomes likely. But this is also why totals across short distances can vary dramatically. You may see reports of 12 inches in one community and 6 inches just 40 miles away. Not because the forecast was wrong, but because that is how banded snowfall operates. Winter storms reward precision. And tonight, the precision zone, the potential jackpot corridor, has shifted. Now we watch to see exactly where that band locks in, because wherever it does, that is where totals will climb fastest. 4. Wind will amplify the impact. Snow totals tell only part of the story. Impact is determined by what the atmosphere does while that snow is falling, and wind is the multiplier. When a winter storm strengthens, the pressure gradient tightens. As the low deepens, air accelerates toward its center. That increase in wind speed can dramatically change how conditions feel on the ground. Even moderate winds of 20 to 30 miles per hour can create significant problems when combined with falling snow. Visibility drops quickly. A blowing snow reduces contrast on roadways, making it harder for drivers to see lane markings or obstacles. In open areas, especially rural highways and elevated roadways, snow can drift back onto cleared surfaces almost immediately after plows pass. This creates a false sense of security. A road may look partially treated until a gust lifts fresh snow across it, creating sudden slick spots and brief whiteout conditions. During heavier snowfall rates, wind compounds the problem. Snow is not simply falling downward. It is being driven sideways, reducing forward visibility and increasing the difficulty of safe travel. At peak intensity, there can be moments where drivers cannot see beyond a few car lengths, and the impact continues even after the heaviest snow tapers. If snowfall is light and fluffy, which is more likely in this colder air mass. It is easier for wind to lift and redistribute it. That means drifting becomes a major concern, particularly in exposed areas and along north-south roadways. Snow that initially measures 8 inches could drift much deeper in localized areas. Another factor is infrastructure. Strong winds combined with accumulating snow can place stress on tree branches and power lines. If any icing occurs in transition zones, even light ice accretion paired with gusty winds increases the risk of scattered outages. This is why storm intensity is not measured by snow totals alone. It is measured by conditions during the worst hours of the event. A calm 6-inch snowfall is manageable. A 6-inch snowfall falling at 1 to 2 inches per hour, with sustained winds over 25 miles per hour, becomes disruptive. The track shift increases the likelihood that some areas will experience stronger winds overlapping with heavier snowfall. That overlap zone is where travel becomes hazardous fastest. And that is where impact escalates beyond what the raw accumulation number might suggest. Snow is the headline. Wind is the amplifier. And together, they determine how serious this event becomes on the ground. 5. The heaviest snow will fall in a short, high-impact window. One of the most dangerous misconceptions about winter storms is the idea that snow accumulates gradually and predictably over a long stretch of time. That is not how high-impact systems behave. In this setup, the storm's energy is concentrated. The strongest lift, deepest moisture, on and coldest temperatures align during a relatively short window. And when that alignment happens, snowfall rates can spike rapidly. This is not an all-day light snow event. This is a focused burst. There may be several hours where conditions appear manageable. Light snow, steady accumulation, slow but functional travel. But once the core dynamics of the storm arrive, the situation can change quickly. Snowfall rates can jump to 1 inch per hour, possibly higher in banded regions, and that rate changes everything. Road crews that were maintaining pace suddenly fall behind. Highways that were just wet become snow-covered within minutes. Surface temperatures already below freezing allow immediate sticking. Intersections become slick. Bridges ice over faster due to airflow beneath them, and the transition from drivable to dangerous can happen within a single hour. This is especially true during evening or overnight hours, when temperatures drop further and traffic patterns shift. Reduced visibility combined with compacting snow from vehicles creates rapid deterioration. The key here is intensity. Total snowfall numbers are important, but how fast those totals accumulate matters even more for safety. 8 inches over 12 hours is manageable. 8 inches over 6 hours is disruptive. That is the difference this storm presents. The short, intense phase is when the atmosphere is most efficient. Strong upward motion enhances crystal growth. Moisture feed peaks. Snow growth layers are saturated and active. Everything aligns for maximum output. And during that period, response systems are stressed. Emergency services slow. Commute times extend dramatically. Secondary roads become difficult to clear. Another important factor is perception. Before the peak window arrives, people often underestimate the storm. They see light snow and assume conditions will remain steady. But winter systems frequently save their strongest push for the middle phase. That is when confidence drops. That is when accidents increase. That is when advisories turn into warnings. The recent track shift increases the likelihood that the heavier snowfall axis overlaps with populated areas during that critical window. which means the period of rapid deterioration may affect more people than originally expected. Timing is everything in winter weather. And in this case, the most impactful part of the storm will not last days. It will last hours. But those hours will define the event. 6. The southern edge is a razor-thin ice line. While much of the focus is on heavy snow totals, there is another zone that may carry equal or even greater risk. The southern edge of this storm. This is where temperature profiles become delicate, where a difference of 1 or 2 degrees, either at the surface or a few thousand feet above, determines precipitation type, and precipitation type determines impact. If the entire atmospheric column is below freezing, snow falls. Accumulation is measurable, visible, and predictable in its effects. But when a shallow layer of warmer air sneaks in aloft, snowflakes begin to melt partially before refreezing. That creates sleet. If that warm layer is deeper, snow completely melts into rain droplets, only to refreeze on contact with sub-freezing surfaces below. That creates freezing rain, and freezing rain changes the situation entirely. Snow disrupts travel. Ice cripples it. Even 1/10 of an inch of ice accumulation can create hazardous driving conditions. A 1/4 inch can bring down tree branches and power lines. Heavier accretion can lead to scattered outages, infrastructure stress, and prolonged recovery times. The challenge with this particular storm is that the southern gradient is tight. That means the transition zone between heavy snow and mixed precipitation is narrow, and it can wobble north or south depending on storm strength and track. If the low tracks slightly farther north, warmer air surges farther inland. The snow line shifts. Areas expecting several inches of snow could instead see sleet or freezing rain. If the low remains slightly farther south, cold air holds stronger. Snow dominates. That boundary is not static. It breathes with the storm. Forecast models often struggle with exact placement of that rain-snow line until the event is underway. Subtle changes in intensity can strengthen warm air advection aloft. At the same time, dynamic cooling from heavy precipitation can counteract that warming. This push and pull determines what falls from the sky, and that is why the southern edge must be watched closely. Ice is quieter than snow in forecast discussions. It does not create dramatic snowfall maps. It does not generate foot-deep totals, but its impact can be more severe. Snow can be plowed. Ice requires treatment, temperature moderation, and time. The recent track shift increases uncertainty along that transition zone. Some areas may remain safely in the snow sector, while others may briefly enter a mixed phase before cooling wraps back in. That brief window is enough to create problems. So while attention centers on massive snow totals in the core zone, the southern edge carries a different type of risk. Not deeper accumulation, but sharper impact. And in winter weather, sometimes the line between manageable and dangerous is only a degree wide. 7. Forecast. Confidence is increasing, but this storm is still evolving. At this stage, the signal for heavier snowfall has strengthened. Multiple model runs are aligning around a similar track. Ensemble guidance is tightening. The core zone of highest impact is becoming more defined. That increases confidence. But confidence does not mean certainty. Winter storms are dynamic systems. They evolve in real time. Their exact intensity, timing, and structure are influenced by subtle atmospheric interactions that cannot be perfectly measured in advance. Even small changes in storm strengthening can alter snowfall placement. If the low deepens slightly faster than expected, the deformation band may pivot differently. If it strengthens a bit slower, the heaviest snow axis could shift by dozens of miles. If dry air intrudes unexpectedly, snowfall efficiency may briefly decrease before rebounding. These are small-scale processes, but small-scale processes drive large-scale outcomes in winter weather. Another factor is mesoscale development. As the storm matures, embedded features often develop within it. Localized pressure falls, enhanced lift zones, or secondary banding structures can form hours before peak impact. These features refine the snowfall pattern in ways that broad-scale models cannot always predict perfectly. This is why final totals are often adjusted within 12 to 18 hours of peak impact. It is not because forecasting is uncertain. It is because winter storms sharpen as they approach. Right now, we are moving from projection to refinement. The broader setup is clear. Cold air is established, the track has shifted, and heavier totals are more likely in the newly favored corridor. What remains fluid is exact placement of the most intense banding and the precise southern transition line. That is normal in winter forecasting. It is also why updates matter. The storm is not finished organizing. As it strengthens, radar trends, satellite data, and surface observations will allow forecasters to narrow in on the most impacted communities. Confidence in a significant event is rising. But the fine details, who sees 8 inches versus 12, who stays all snow versus briefly mixes, will finalize as the system matures. This is the phase where attention is critical, because winter storms rarely announce their exact intentions days in advance. They reveal them hour by hour. And as this one continues to evolve, every update will sharpen the picture. The track has shifted, the setup is primed. Now we watch the atmosphere finish writing the final chapter of this event. This storm has shifted, and that shift has consequences. Snow totals are increasing in the newly favored corridor. Banding will determine who sees the highest amounts. Wind will amplify the impact, and timing will decide how quickly conditions deteriorate. What looked manageable yesterday may not look the same tonight. As this system continues to organize, we'll be monitoring every adjustment, every radar trend, every model update, every shift in the snow and ice line. Because in winter weather, miles matter. If you're in the potential impact zone, now is the time to prepare. Review travel plans, stay alert for updates, and don't rely on outdated forecasts. This situation is evolving. Make sure you're subscribed so you don't miss the next critical update as this storm unfolds. We'll continue tracking it closely. Stay informed, stay prepared, and stay safe.